everyone, welcome back to another Planetarium live stream. My name is Jessica, I am the director of the Planetarium, and with me tonight are two of our students who are some pretty familiar faces if you have seen our live streams in the past, but I will let them introduce themselves, and we'll start with this guy here to my left.
Hi, my name is Eli. I'm a physics undergraduate student at UMD.
Hi, my name is Lindsay. I'm a physics graduate student at UMD.
So tonight we are going to be talking about aliens. So I got my little friend here in the corner with me. But we're going to take a look at kind of where some of our initial fascination with Martians came from, some of the things that we have looked into as far as like what it takes for life to survive, because we kind of need to know that, and then look at some possible places that life could be, where aliens might exist. I don't know. We'll see. But before I get started, if you do have any questions throughout the show tonight, leave them down in the comments. Eli's going to be watching those for me and will let me know if you do have those questions. And if we don't get to them right away, no, don't worry. We will have time at the end to answer the questions as well. So with that, let me get switched over. All right. So, as I said, we are going to be talking all about aliens and whether they could really exist, or if we're the only life in the universe. So a lot of times when we say alien, these are some of the images that may come to mind. You have your classic little green man. We also have the kind of grayish big head alien. That's a pretty common depiction. If you're into horror and sci-fi movies, the alien may pop in your head. And a lot of these actually started with one of the earliest depictions of aliens, which was the middle little green man that we have there. And that actually started out from some interest and intrigue we had in the planet Mars. So you see, early on, when we started looking at Mars through telescopes, we started to see, and early astronomers started to see these markings across the surface. And they labeled them different things. They would make maps of these markings across the surface. And one of the earlier ones was in 1877 by an Italian astronomer named Giovanni Schiaparelli. And he decided to label these markings across the surface as canali, which is Italian for channels. Well, when his work was translated into English, the word canali was not translated into channels. It was translated as canals. And that may not seem significant to you, but there is actually a subtlety there that makes a big difference, because a channel is a natural feature just carved by running water. A canal, on the other hand, is a man-made feature. And so by this mistranslation and calling these canals, they were inadvertently implying that there had to be some intelligent civilization on Mars building these waterways. And that kind of just took off. One of the biggest advocates was Percival Lowell, who actually built an entire observatory just dedicated to studying Mars, to making these detailed maps of the surface, and spreading this idea of these Martians. And it became just like almost common knowledge that there was an intelligent race on Mars, so much so that it invaded into popular culture, becoming a part of books and radio dramas and all sorts of things. It became even just headline news that we had found evidence for life on Mars. So this all leads up to that depiction of the little green man that started this off. So Edgar Rice Burroughs wrote a series about a man who was stranded on Mars. And the first kind of type of life he finds, Martians that he finds, are these little green men. And that kind of became synonymous with Martian and then synonymous with alien. And all of this kind of what we thought was common knowledge, this what went from fascination to, in some cases, fear of this intelligent race on our neighboring planet, all very quickly came to an end in 1965 when Mariner 4 gave us our first spacecraft that flew up close and personal with Mars, taking some pictures of the surface. And those pictures that we got back did not show waterways. They did not show canals. In fact, they didn't really show any running water on the surface. The surface of Mars was dry, barren, nothing there, no signs of life, no signs of canals or channels or anything. And we realized that those markings that early astronomers had been seeing were a mix of imperfections in the telescopes they were using, and also our brains making patterns out of random things that aren't really there. Our brains are really good at taking a bunch of random points and making them mean something, like connecting them in a line or making us see a face that's not actually there. And so we think that that's what happened. And even though in 1965, when we realized that there aren't actually Martians there right now, we still kind of held on to that fascination with Mars. And it really, I think, fueled our kind of alien frenzy, and has helped keep it pretty persistent in our culture. And so if we look back again at some of these common depictions of aliens, there's something that we always kind of assume when we talk about alien life. We always kind of initially, we'll say initially, describe alien life as intelligent, as like us, just maybe looking slightly different, with a head and two legs and two arms, and being, having that intelligence there to build technologies and different ways of communications and traveling and all of these things. But that's not all life is. There are so many varieties of life, from simple single-cell organisms all the way up to the complex, Homo sapien that we are, that we kind of need to keep that in mind when we start thinking about life on other worlds. Because it would be just as exciting to find any form of life than to necessarily find little green men. At least to me as a scientist, I would be excited by finding any form of life. And with that in mind, let's kind of take a look at what might be needed for life to develop and kind of how easy or difficult it is. And the best way we have of learning about that is actually our planet. Because as far as we currently know, Earth is the only planet that has developed life. And so we can use that as a case study to figure out, did life develop here easily? What was the first kind of life to form? How has it changed? And that can give us some kind of key clues into what to search for in other places. And so looking at Earth, we actually think life developed pretty early on. We have evidence that suggests that we have fossil evidence that shows life was around by about 3.5 billion years ago. So once the Earth was about 1 billion years old. We have other evidence that suggests that it could have been around even earlier, at about 4 billion years ago, when the Earth was about 500 million years old. And the very first life that developed was very simple single-celled organisms that we believe originated deep in the ocean around volcanic vents. because that provided heat and energy, and the protection of the ocean protected from things that were going on in the surface. Because at first we didn't have an ozone layer protecting us from UV light. Any life on the surface could have been destroyed by that UV light, but being deep underwater, they were protected from that. We also had a lot of impacts going on early in the history of our planet, and being deep underwater would protect you from that as well. So we think that that's kind of what the first life looked like and where it originated. And then we see, or actually one other thing, another important feature of this early life was that it actually did not depend on oxygen. It didn't use oxygen. It used carbon dioxide. It was a carbon dioxide-based life because there was no oxygen in our early atmosphere. There was carbon dioxide, nitrogen, some other stuff, water vapor, but no oxygen. So the first life to develop was actually carbon dioxide-based. The first oxygen-based life didn't come around until about 2.7 billion years ago, when the first kind of cyanobacteria formed. Or sorry, no, not oxygen. This is still carbon dioxide-based. We have photosynthetic life that developed about 2.7 billion years ago that started to produce oxygen through the through photosynthesis, right? They take in carbon dioxide and then create oxygen. And as this type of life started to flourish, we started having a lot of oxygen being produced by this photosynthetic life. And that allowed oxygen to build up in our atmosphere. And so the oxygen-based life came about 2.45 billion years ago. And I know I'm throwing a lot of numbers and a lot of things out. The thing to remember is the very first life was carbon dioxide based, and it wasn't until we had oxygen from photosynthetic life that built up our atmosphere, oxygen in our atmosphere, that we ended up developing oxygen-based life. That came much later. And even then, it was still very simple life. It wasn't until about 500 million years ago that life really started to flourish and diversify in what we call the Cambrian explosion. And that's when we started seeing bigger, more diverse life. That's when things like dinosaurs and mammals started coming around. Dinosaurs, of course, dominated the planet. They were the kind of king race of the planet for about 100 million years before they died off, which allowed then mammals to start to really grow and diversify without the threat of dinosaurs, leading to life that we see today. And so we're doing all of this, going through all of this, to really get to the bottom line of simple life seems to develop pretty easily. And then it takes a lot of time for that life to become more complex and possibly even develop to becoming so complex that we can classify it as intelligent life like us. So simple life, simple single-cell bacteria, simple organisms, those seem to be the type of life that would be much more common and much easier to find because it seems as if it develops pretty easily. But finding something like the little green man or the intelligent species might be a little bit more difficult, and that might be a little bit more rare because that seems to take a lot more time to develop. Now again, all of this is just based on Earth. We have one data point here. As we continue our search and learn more about these requirements, we'll be able to kind of hone in and really get a much more confident sense of what it takes and what's going on. And so with all of that, we can take life on Earth, how it's developed, how it first formed, what it's turned into, and use that to set a kind of list of requirements for what we think a world needs in order for life to develop there. And the exact requirements do vary depending on what kind of life you're talking about. If you're talking about something like us, we have very strict requirements. We have to have oxygen, and we have to have an atmosphere with oxygen. We have to have a temperature in a very, very narrow range for us to survive. We have to have a lot of diversity in vegetation and food requirements. So looking for something like us, there's a pretty strict requirements there that really narrow down your search. But we want to look for any kind of life, which really widens our our search requirements. And so what we think the most kind of basic requirement for life is liquid water, because every type of life that we find on Earth uses liquid water in some way. And the second is an energy source, whether it's energy directly from the sun, from volcanic vents, from eating other types of life. You have to have liquid water and some form of energy source. Now, if we want our life to live on the surface of our world, we think that that takes a little bit more than just water and energy, because the surface of a world can be quite dangerous, especially if you don't have something like an atmosphere that can not only just provide, air to breathe, but also provides protection. Like our atmosphere protects us from a lot of the high energy light coming from the sun, like UV rays and X-rays and gamma rays. It also protects us from some of the chunks of rock that are floating in space. They burn up in our atmosphere before they hit the ground. And the other thing is something called a magnetic field, which really acts as a shield to protect the planet, because stars give off a wind, and that wind can actually strip the atmosphere from a planet and also start to kind of eat away at the surface. And so this magnetic field protects the world from that. So this seems like we have some pretty difficult requirements here, pretty difficult things to search for. But we actually think we have found quite a few places that meet these requirements. Now, when we're looking for these worlds that might fit these requirements, there's a few kind of tests that we use to see if they could meet these requirements we've talked about. One of these tests is something called the habitable zone, or the Goldilocks zone, with the idea being that a world in the habitable zone would be the right temperature for liquid water to be on its surface. Right? If it's too close, it's going to be too hot, and that water will be instead water vapor in the atmosphere instead of liquid water on the surface. And if it's too far out, it'll be too cold, and that water will just freeze into ice. And so we look for things that are in this kind of habitable zone, this Goldilocks zone, where the temperatures are just right for liquid water. The other thing we can do is narrow down our search based on the size of the world. Because a really, really small planet, like, say, Mercury, is never going to meet these requirements because it's just not big enough to have created an atmosphere or to create a magnetic field for very long. And it's just not going to meet those requirements. There's actually a minimum size that we look for a world that could possibly develop life. And so with that, we actually have our own neighbor that we think might have met these requirements, and that's Mars, the planet that started all of this fascination with alien life to begin with. And while Mars doesn't meet those requirements today, we have a lot of evidence that Mars used to be much, much more like Earth in the past, with lots of oceans and rivers and lakes of liquid water across the surface, a thicker atmosphere, temperatures more Earth-like. And that leads us to believe that maybe while all of this was going on, there was enough time for simple life to have developed and formed. And so a lot of the later missions to Mars, like Curiosity and like Perseverance, that's heading there right now, have equipment to run tests to see if there is any trace of past life, whether it's like microfossils or molecules or things that life gives off that can't be explained by natural processes. And so we look for that sort of thing. We haven't found it yet, but we're still are learning a lot about what's going on there, and that allows us to make our test even better to hopefully search. I know there are a lot of people who also kind of hope that the life, or hold on to this idea that the life might still be there, because we think that there are pockets of liquid water underneath the surface where it might just be a little bit warmer, might be warm enough for there to be a little bit of like underground lakes. And if life had developed, maybe it migrated down into those. We don't know, but we're still trying to find out. So
Jessica, do you mind if I interrupt? Oh, sorry, I didn't mean to cut you off.
Yeah, no, go ahead.
We just have a question from Lori Sanchez. How do you know this about Mars?
So when we have sent rovers and spacecraft to Mars, one of the first kind of pieces of evidence we had were features on the surface that look like shorelines and dried up riverbeds and channels where we had like one-time massive flooding, that sort of thing. And so those features got us excited because they look like features carved by water that used to be there. And then once we had rovers on the surface, they were able to test these areas, and they found minerals that only develop in the presence of liquid water. We have found other rock features like, why am I blanking on the... Lindsay, help me. You're my geology queen.
What feature? Or
the rocks that are layers.
the geologic layers?
Yeah, the ones that are formed by layers of material.
Right. At the bottom of lakes.
Yeah.
Is where.
Yeah, and so they're formed by water kind of depositing debris over and over and over, and it builds up these layers, right?
Yep.
Yeah, I can't remember the name of that rock.
Yeah, there's also the craters that are in the area of Mars that we're pretty sure there was water are more eroded than the craters that are on the kind of higher elevation areas of Mars. So that's another clue.
Yeah. So we have so much evidence at this point that we are very, very certain, which is really cool. But no, that was a really good question. So other places we have found exist around other stars in what we call exoplanets, extrasolar planets. And in our search, we have found thousands and thousands of planets around other stars. And we have a list of about 55. That list has probably grown since I last looked it up. But about at least 55 of these planets could be habitable, meaning they are in that Goldilocks zone and they are bigger than that minimum size needed, which gives us a list of possible other planets outside of our solar system that could host life. Now, we don't know for sure if any of these do, And we really won't until we get kind of better telescopes, bigger and better telescopes, to let us study them in more detail, because right now they're too small, too far away, too dim. It's really difficult to study them. But as our technology improves, we're going to be able to do that better and better. What's really exciting is one of the planets on this list is around Proxima Centauri, which is the closest star to us. So the closest star might have a Earth-like planet around it, which is good news for us if we ever do need to kind of skip home and find a new system to live in. That would be a good place to look, since it's right next door to us. Now, that isn't the only way that we could have life. I've been right now specifically talking about living on the surface of the planet. But as we've seen, early life on Earth didn't develop on the surface. It developed deep under the oceans. And that actually opens up a lot more possibilities if we think about worlds that could host life either underground or under the oceans, not on the surface. And we actually have quite a few places in our own solar system that meet these requirements. The most exciting of which is one of the Galilean moons around Jupiter, named Europa. Europa on its surface is covered in a layer of ice, but underneath that sits a huge ocean of liquid water. I'm talking huge. We think that there is twice as much water on Europa than there is on the entire Earth. And again, where you have an abundance of liquid water, there's likely to be kind of those hot vents, which is what's heating up that layer, allowing it to be liquid, so you have an energy source. You could have life. So there could be alien fishes, or at least alien bacteria, swimming around in that ocean underneath that icy crust. And we are trying to get there to figure out, to test it. NASA and the European Space Agency are working on a future mission to Europa that is going to land on the surface, either drill or melt their way through the ice, and then explore that ocean below. And I'm very excited for this. I hope that it can happen sometime in my lifetime, but there is a lot involved in doing this. Not even just, the technological aspects of getting there and landing and melting or drilling through the ice, but there's also a lot of other things to take into consideration, especially when we are specifically looking for life. We have to make sure anything we send is 100% sterile. We cannot risk introducing any form of Earth life onto this other world, either influencing our results, or at worst, destroying what's there by this new life being introduced. Now, there are a few other similar places. We have Saturn's moon Enceladus and Neptune's moon Triton. Enceladus, we think, also has a subsurface ocean that could also host life. And same with Triton. We think that there might be some subsurface ocean there. Now, we are definitely a little bit more excited about Europa because it's closer and seems to have the biggest ocean of all of them. But these are some other possible places where subsurface life could develop just within our own solar system. And then we have Titan, which is another moon of Saturn, which poses an interesting question about what life, or how and what life really could be, because Titan has liquid on its surface, but it's liquid methane, not liquid water. But who's to say there couldn't be a form of life that develops that depends on liquid methane the way we depend on liquid water? Who knows? And so it's another kind of place that we're interested in learning more about, to see if some other unthought of or unseen type of life on Earth could develop somewhere else. And in fact, we have a new mission that was announced, Dragonfly, which is a quadcopter that's going to fly around this moon and take lots of data and pictures and information for us. And it can do that because Titan actually has a thick atmosphere. It's the only moon that does. And that means you can fly through it. Now, I'm going to end on probably my favorite thing to talk about, and I don't have much time. But all of this has been supposing, life on a planet or underneath the surface. We haven't talked about life maybe surviving the vacuum of space itself, which seems impossible, but it exists. What we're seeing here is a tardigrade, also known as a water bear. I think they're adorable. I love them. But what's crazy is these are some of the most resilient little buggers. They can survive extreme cold, extreme heat, acidity, salinity, and they have even survived the vacuum of space. We sent a bunch of these guys up to the International Space Station. They were left out in the vacuum of space for a few days, brought back home, and then they woke up. They were still alive and didn't seem to really be harmed by it. And so this opens up just so much more when we see just how resistant and resilient some of these, what we call extremophiles, are. So yeah, that's my not so quick spiel on alien life. So to answer the question we posed, could alien life be out there? The answer is we don't know for sure, but quite possibly. There are a lot of places that seem Earth-like that could harbor life. There's a lot of places that have some other type of possibilities. And if we think about these extremophiles like tardigrades, that opens up even more possibilities. And with hundreds of billions of stars in our galaxy alone, at least half of which have a planet, and hundreds of billions to trillions of galaxies in our universe, my personal opinion is, yeah, there's life out there. It's just the universe is too big for there not to be. So let's switch back over, unpin myself. Lindsay, I know you love this topic as much as I do. Do you have anything else to add?
I was wondering, do you happen to know how often a tardigrade needs water?
I don't, off the top of my head.
Yeah, I wonder how long it could survive in space.
I don't know. It would be really interesting. I'm sure they've done more experiments, and I just haven't seen the results. But the fact that they survived at all is crazy. What they're basically able to do, and correct me if I'm wrong, but they pretty much dry themselves out, right? And kind of shut down all of their basics, or everything but the most basic systems, until they are back into conditions that are suitable, and they're able to just absorb up the water and turn everything back on and just kind of come back to life. It's crazy. And they're adorable. I love them. All right. Any other questions?
Nope, just a few exclamations about tardigrades.
They should be everyone's favorite.
I don't know if I can side with you on the cute. They look kind of terrifying.
No, they don't. They look so cuddly.
But I always think of a big one coming after
you. It would be cuddly.
I don't know. It's a little scary.
It's still one of the things that I'm most disappointed about having to cancel our, I guess at this point we will say cancel our spring astronomy day.
Yeah.
Is we did have the biology department was going to bring some tardigrades for people to look at. And I'm so sad that we weren't able to make that happen. But now that I know they can do it, they will be doing that for us. The next time we can actually do a big event like that, we are having some tardigrades. And I'm super excited. I may not leave that table.
Yeah. We just got another question about the phosphine.
Oh, I forgot to talk about, yes. So this was a quite well-timed announcement that we heard, was it yesterday or 2 days ago? It wasn't that long ago. It was announced that phosphine gas was found in the atmosphere of Venus. And as far as they can tell right now, there doesn't seem to be a very likely natural source for it. Meaning, right now, one of the scenarios is some form of life in the atmosphere, which just kind of is crazy, honestly, that it seems to be the first signs of life we may have found is on Venus, the most inhospitable place, like, in our solar system. So I will say that we don't know anything for certain right now. Unfortunately, this is a lot of case of the media likes to overhype these findings. We are still, these scientists and astronomers are still working on this, getting more data, testing more models, doing what they can. But yes, that is a possible explanation. And I wish I could tell you more, but we are in such early stages with this that we don't have a lot of information right now. Ooh, how big is a tardigrade? Lindsay, do you know? I know they can be seen with the naked eye.
Wait,
they're teeny tiny.
I did not know you could see them with the naked eye.
Teeny tiny.
Kind of brain.
Yeah.
I did want another way that you can get life on a planet is for it to come from another planet.
Yes.
So, like, as life, if something struck Earth and debris from Earth ended up flying through space and going to another planet, there could be life on that debris that ends up landing on the other planet.
Like a tardigrade.
So, right. So that's another way that you could get life. Doesn't necessarily have to emerge on that planet, but it could come from another planet.
And we know that material does make it to other planets. We have meteorites here on Earth that we're fairly certain came from Mars. So it happens, especially in the early universe. Lots of events, lots of impacts, and really, really big ones. So yeah, that's another possibility. I should add a slide about that. So if you do have any other questions, let us know. I'm going to give you a little bit of a preview of what's coming up over the next week. So Saturday, Lindsay and Eli are going to be taking us on a tour of the scale and wonders of the universe to really get a sense of exactly how big the universe really is and some of the awesome things that we can find in it. And then on Wednesday of next week, we are doing Moon 101. It's going to be kind of Moon Week next week. Wednesday, we're going to do a show, just everything you might want to know about the moon. How it formed, what the geology is like, which I'm going to let Lindsay take because, as I said, she's our geology queen. And all of this is leading up to our big event on Saturday. We're going to have our very first socially distant stellar Saturday, where we're going to have some tables set up outside the planetarium, outside in the nice open air. We're putting together activity kits for you to pick up so that you can become your own lunar explorer. And these are going to include things on learning about the phases of the moon, building your very own straw rocket to get you there, a lander to land on the surface, and then some exploring of the surface with making your own moon rocks and some information on what moon rocks are really like. So we're very excited. We're also going to have a kind of hands-on crater demo that's there. That's going to be a lot of fun. So we're excited about this. We have more information up on the event on our page if you want to check it out. We are asking that everyone who comes to please follow the One Direction flow, to wear masks, to socially distance, just to keep everyone safe. And then that evening is International Observe the Moon Night, and so we will be doing a telescope stream of the moon that night, weather permitting. Otherwise, we'll be here to answer your questions and go over some of the fun things that we gave out at the Stellar Saturday event earlier that day. And the last thing I want to mention, last little plug, is we do have our stellar distancing t-shirts that are still for sale. We are using these to help us raise money to fund virtual field trips for K through 12 schools, since a lot of them do not have a budget for field trips this year, and we'd like to still be a part of their school year and help them learn about our fascinating universe. And they're also going to help us fund these like Stellar Saturday events and these live streams. But right now, they're mostly, we're raising it for the field trips. And you can find the link to order your own in the description, in the video description. So with that, I think we will wrap it up. Thank you everyone so much for joining us. We hope you enjoyed the show. We hope you have a wonderful rest of your evening and week, and we will see you again next time. Bye.